Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to use YOLO11 for object detection, and then we will use a supervision for annotator, and then detected object points we will send or we will access in Pygame window. So before we move to our practical friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I mentioned, today we will use YOLO11 object detection method, and then we will use here supervision annotator, and then we will send detected object points inside Pygame window. That's it. So let's get started. So first, open Thony Python IDE, go to the tools, manage packages, and search for opencv-python. Hit enter. First package, click on install button. It will install opencv. Then ultralytics package, ultralytics package for YOLO. Search for ultralytics. Click on ultralytics. Install ultralytics. Done. Then we will use here CV zone. So CV zone, hit enter. First package, click on install button. Done. It will install CV zone. Then as I mentioned, we will use here supervision. So we want to install supervision package also. So search for supervision. As you can see, supervision, simple supervision, and just click on search on PyPy. It will search for supervision. First package, click on install button. Done. It will install supervision on our Windows 11 machine. Then we need our Pygame package also. So Pygame, hit enter. First package, click on install button, and then it will install Pygame on our Windows machine. So this is how we need opencv-python, ultralytics package, CV zone package, supervision package, and Pygame package. This is the packages which we need for this project. So we have successfully installed our packages. Now for today's project, I have created a new repository. I will mention the link, YOLO11 object detection Pygame. Simply copy paste the link inside web browser, then go to the code and click on download zip. It will download our zip format repository. So friends, we successfully download our repository. Minimize all these things, open file manager, go to the downloads, and this is what our repository. Right click, WinRAR, extract as a folder name, then go inside folder. Again we have same folder, and this is what our basic code for YOLO11 object detection, and vidp.zip, this is the video zip file. So right click, WinRAR, extract as vidp. It will extract our folder. This is what our video file. Right click, cut, and go back and just paste the video file over here where we have our test.py. Simple. So let's just play our video file, then you will get the idea what basically we are going to achieve. So here it is. As you can see, we have here persons. So we will detect a person with the help of YOLO11 object detection model, pre-trained object detection model, and then we will use ultralytics tracker. So now each person we have unique ID, and then as I mentioned, we will use here a supervision annotator, and then we will send detected object center point in our Pygame. Simple. So let me close the video file and let's just open our test.py. So this is what our basic test.py code. Ultralytics, import YOLO, CV zone, numpy as np, import CV2. Then we will use YOLO11s.pt, which is pre-trained object detection model, and this is what our video file name. And then this is how we call our boxes, class IDs, track IDs, all these things, basic code. And then we will have basically x1, y1, x2, y2 from box. We will call these boxes with the help of for loop. So these boxes is now box, this class ID is class ID, and track ID is basically track ID. So this is basic code for object detection. Now we have rectangle, we have class name, we have their center point also. So if I start the code, first it will download our pre-trained object detection model. As you can see, it's downloading our model YOLO11s.pt. So friends, as you can see, we have rectangle for each person. So it means we successfully detecting a class, person class. Done. So now this is, as I mentioned, this is what our basic code. Now here, this is what supervision.roboflow.com, their official website, and from this website, annotators, as you can see, annotator. So I will use here box corner annotator, as you can see, box corner annotator. So instead of drawing simple rectangle, we will draw this kind of box. As you can see, this kind of box. You can simply draw color. Here it is. As you can see, you can simply draw circle like this way. You can simply draw a dot. You can simply draw a triangle. Then here we have a round box also. Then we have our normal bounding box. But my personal favorite is basically box corner. So for this project, I will use a supervision for drawing a box corner. Simple. So we install our supervision package. Let's just minimize web browser. So how do we use supervision? Simple. First we want to call our module. So let's just import our module. So import supervision, as SV. Import supervision as SV. This is how we import our module, supervision as SV. Simple. And then, as I mentioned, we will use here box corner annotator. So we want to create a variable, and that variable represent our SV box corner annotator. Simple. So let's just create a variable. Let's say over here, I will create a variable which is box corner annotator. Box corner annotator is equal to our SV box corner annotator. So SV dot B capital, C capital for corner, and then annotator A capital. That's it. So box corner annotator, it is just a variable, is basically now SV dot box B capital, corner C capital, annotator A capital. This is how we want to create a variable which represent SV dot box corner annotator. Done. Now we create our variable. Now we want to simply mention here, annotate the frame with the corner style bounding boxes in OpenCV. So for that, let's just go over here. Here we have our boxes, class IDs and track IDs. After that we will create again new variable which is detections. So this detection is basically what? This detection is basically SV dot detections. SV dot detections. Here we want to mention D, a capital D. Detection is equal to SV dot detection. So what is basically SV? SV is basically our supervision. We import supervision as SV, as simple as. So if we want to call supervision, we want to call SV. So from SV dot detections, and inside that we will pass our boxes, our class ID and our tracker ID like this way. So let's just first pass our boxes variable, this one boxes. So boxes basically xy is equal to these boxes, xy is equal to these boxes, simple. And then we will mention our class ID, this class IDs. So class ID, for supervision we want to mention the class ID as a array format. So like this we will mention class ID is equal to np.array, and we will mention our class IDs. That's it. And then we will mention what else we want. We want our track IDs. So again tracker ID, or let's just go like this way. Here I will mention tracker ID. It is just a variable. So tracker ID is basically our track IDs. So tracker ID is equal to, same way, np.array and our variable which is track IDs. That's it, track IDs. So we mention detection is just a variable. Detection is equal to our SV. SV means our supervision as SV. So our SV dot detection, D is capital, and then inside that we want to pass boxes. So xy is equal to boxes, then class ID is equal to np.array, this class IDs, and then tracker ID is equal to np.array, track IDs. That's it. Now simply we will create here a new variable again, which is annotated frame. Annotated frame is equal to our box corner annotator dot annotate, simple. So we create here a variable which is our sv dot box corner annotator. So if I want to call this annotator, so I just want to call this variable. So copy as it is and mention over here. Annotator frame is equal to our box corner annotator dot annotate, and inside that we want to pass our frame, because all these things we want to show on our frame, and then after that frame, and then we want to pass these detections. So let's just pass detections. That's it. So now we are drawing a bounding box with the help of supervision. So now there is no need to draw a rectangle with the help of civ2 dot rectangle. So I will simply remove this civ2 dot rectangle method. Remove. Let's just save the code, and here, because now we want to mention our annotated frame, so here I will remove the frame and I will mention the annotated frame. Then it will show the result, simple. So save the code and run the code. Annotated frame, let me check. Oh, there is typo mistake, that's why the error. Let's just save the code, let's just run the code. And as you can see friends, as I mentioned, now there is no normal rectangle. With the help of supervision, we are drawing here a rectangle like this way. This is the rectangle. This is basically box corner rectangle which we are drawing with the help of supervision. Let me start again the code. Here it is, as you can see, simple. So for that, simply you want to import our module, which is import supervision as sv. Done. Then we will create a variable, because we want to achieve here this box corner annotator. So we create here a variable box corner annotator. This is just a variable. So this variable represent our sv dot b capital box, c capital corner, annotator capital a capital annotator, sv dot box corner annotator. So now if I want to call this sv dot box corner annotator, I just need to call this variable, as simple as. And then here we mention over here a detections variable. So this detections variable is basically sv dot detections. Here it is also D capital, sv dot detections. So inside that we want to mention our boxes, class ideas and track ideas. So our boxes is basically xy is basically our boxes. Then class id, we want to pass class id as a array format, so np dot array and then just pass class id as. Then same way tracker id is equal to np dot array and pass track id as. That's it. Now all these things is now our detections, this detection variable. Simple. Now then we create annotated frame. It is just a variable. So annotated frame is equal to our box corner annotator, So our box corner annotator dot annotate, and inside that we want to pass our frame, this one, and then we will pass detections. Simple. Now all these boxes, then class id and then track id, we are sending into our detections, sv dot detections, and then these detections will be draw all the things on our frame, and then all these things is now annotated frame. For that we change normal frame variable over here, not variable, basically we change here our frame and we mention here our new frame variable, which is annotated frame, because this annotated frame is now our supervision frame. Simple as. So now this is how we are now drawing a supervision box corner rectangle, as you can see on our person object. Done. Now as I mentioned, now we want to send this point or this person point inside our Pygame. So for that, here we call center x and center y. So center x and center y is basically detected object center point. Simple. So center point x and center point y is basically x plus x2, x1 plus x2 divided by 2, and y1 plus y2 divided by 2. This is how we will get our detected object center point. And then c is equal to our names, names is equal to basically model dot model names, and then we will pass class id. So now c is basically names with a class id. So it means if we detect a person, so person, it has 0 class id, so it will search for 0 and the names index, and then we have person name, person class name. Simple. Now as I mentioned, we have done with supervision. Now we will go with Pygame. So let's just start with Pygame. So for that, first we want to create a simple window for Pygame. So let's just say over here, I will create here a new Pygame window. Let me make like this way because there is lots of face. So I will make like this way, and then from here we will create our Pygame window first. So Pygame dot int, and then we will mention Pygame display. So Pygame dot display dot set caption, and then we will mention name for our display. So let's just say Pygame detection, Pygame detection visualization. Pygame detection visualization. This is what our window name, as simple as. And then we want to mention the Pygame window size. So after that we will mention Pygame window size. So screen width, and then screen height. Screen width and screen height is equal to the height and width of our OpenCV frame. So we mention OpenCV frame width is 1020 and 600 is the height. Simple. So same we will mention for Pygame window size. So screen width is basically 1020 and 600 is the height. Done. And then now we will create a screen. So screen is equal to Pygame dot display dot set mode, display dot set underscore mode. Screen is equal to Pygame dot display dot set underscore mode, and inside that we want to pass, as a tuple format, we want to pass our screen width and screen height. So just copy the variables and just paste it over here. Done. And now at the end here we will mention Pygame dot quit. Pygame dot quit. Now if I save the code and if I run the code, Pygame is not defined. Let me check over here. I think we forget to call our module. First we want to import our module, that's why there is error. So import Pygame. Now if I save the code, if I run the code, and as you can see, we have now, this is what our OpenCV frame and this is what our Pygame. As you can see, the name which we mention over here, Pygame display set caption. So our Pygame display name is basically this, which we mention over here, this one. Here it is, as you can see, Pygame detection visualization, and on the Pygame window we have the name which we set as a caption. Let me start again a file. Here it is, as you can see, Pygame detection visualization. Done. So now we created a window for Pygame, or we can say we created a display. Done. Now what is next thing? So now I want to access detected object, this center X and center Y in Pygame window. For that we will create a function. Simple. So let's just create a function over here first. Here we will create a function, and function name is basically draw circle with border. Draw circle with border. So draw circle with border. Draw circle with border. And inside that we will pass surface, then center, then radius for circle, then border color, then we will mention here border color. After that we will mention fill color, and then we will mention border thickness. So border color, after that fill color, and then we will mention border thickness is equal to 2. So what basically we are achieving here, as I mentioned, we want to access detected object center point. Simple. But I just don't want to access the center point. I want to draw the center point as a circle on my Pygame window. So for that we are creating here a function which basically draw a circle with a border. For that we mention over here a surface, then the center, then the radius, then border color, and then fill color and the border thickness. As simple as. Now we want to mention here for this function, after that, like this way, enter. Here we will mention Pygame dot draw dot circle, Pygame dot draw dot circle, and inside that we will pass surface, then border, color, then center, then radius plus border thickness, that's it. And then we will mention, after that we will mention again Pygame dot draw dot circle, and then we will mention surface, then fill color, then center and radius. Okay, done. So why do we call here Pygame dot draw circle 2 times? It is simple, because we will create here a circle which has outer circle and inner circle. So inner circle, for drawing inner circle we create this method, Pygame dot draw circle, surface, fill color, center and the radius. And the outer circle means we can simply say the border of the main circle. For that we create here Pygame dot draw circle, and inside that we mention surface and the border, simple border, color, center, radius plus border thickness. You will get the idea when we draw a circle with the help of our detected object center point on our Pygame window. We will get the idea, simple. So this is the function done. Now here what we want to do, let's just go down, and here we will create. So after C is equal to names class ID, we will simply call our function which we just created, which is draw circle with border, this one, the function which we just created. We will call this function, just copy and paste it over here, and inside that we will pass our screen, and then we will pass our center X and center Y. So just copy as it is, center X and center Y, like this way, copy it, and then we want to mention the radius and the border color. Radius is equal to, let's just say 10, and then we will mention border color, is equal to black, border color is equal to black, and fill color is equal to pink, pink, simple. And then what we want to do, we want to mention the color over here. Let's just say over here pink is equal to 255 105 180, 255 105 180, and the black color is equal to 0 0 0. Done. And the screen is this. We mention over here our screen here. draw circle with border. This is what our function which we created over here. And then we mention over here a screen. So this is what our screen. So we want to mention the surface. So surface is basically our screen. Then the center. So center is basically our center X and center Y, detected object, because what we want to access detected object center point, as simple as. So center is basically detected object center X and center Y. Then the radius, so radius, thickness, not thickness, basically radius, which I have mentioned 10, as simple. And then the border color black, which we mentioned border color black, so black 0 0 0 all the way black. And then we mention here fill color, here border color black and fill color pink. Simple. Now because we created here a black window, so it will not show the detections, it will not show the draw circle, it will basically not show the circle which we are drawing. So we want to create here a white window. So let's just say here where we have our result, here I will simply mention screen, our screen variable, which is our screen. So screen dot fill, and I want to mention the white color. So 255, 255 and 255. Now our screen will be, our Pygame display will be white, as simple as. Now if I save the code and if I run the code, black is not defined. Let me check over here, there is something typo mistake, that's why the error. We mention over here all the way capital, and here we create, I think, yes, black, yes, I need to mention all the way capital. Done. And then let me check here, ping is good, K is also capital. Now if I save the code, if I run the code, one more thing friends, we mention over here, let me stop the code first. We mention over here screen dot fill white screen, but still our Pygame display is black. Why? Because we want to update here our display. So for that we have here cv2.inShow method. Here we are going to simply update our display. So Pygame dot display, Pygame dot display dot flip. Done. Now if I save the code, if I run the code, now as you can see, there is a pink color circle with black color corner. So this is what our points, this is what our center X and center point which we are drawing on Pygame window, which we are drawing. This is what our persons basically. Okay, so now what I want here, I want to show the track ID which we are basically showing on our frame, open CV frame, which also I want to show on my Pygame. So for that, what we will do over here, we will simply create here a label. So here we are drawing the circle. We have now our circle on Pygame. Now here simply we will create a label. Label is equal to like this way. ID is just a name, text name, and then we will mention track ID. So track ID, this track ID, this one, track ID here, track ID, that's it. And then text surface, text surface is equal to font dot render, and we will mention label, this label, the label which we create over here, this label, and then after that mention true and then black. That's it. And because we mention over here a font, so we want to create here a font variable also. So ping black, after that we will create a font is equal to pygame dot font dot sys font, S capital, sys font, F capital, sys font none, and then 24. Done. None and 24. Done. Now we create a font. Now after that we will simply mention screen dot build, and then we will pass text surface, this text surface. So just copy it as it is, text surface, and then we want to show the text on center X and center Y. So center X and center Y, just copy as it is, copy as it is. Done. Now if I save the code, if I run the code, now here it is. As you can see, we have track ID. We have track ID for each detected object center point, but we will make more beautiful way. So for that, what I will do, center X, I will mention center X plus 15, and then center Y minus 10, center Y minus 10. If I save the code, if I run the code, now as you can see, it's really look good. It's really look good. This is what center point for detected each person and their track ID. Now I also want to put the track ID on our main frame rectangle top left corner. For that, simply first stop the code, and here after that I will mention screen.build. After that we will mention cvzone.put text rect, cvzone.put text rect method, and we are going to put the text on our annotated frame. So copy the annotated frame, mention over here, and then we will mention our track ID as a text. So ID is just a text, and then we will mention track ID. This one, this is what our track ID. This track ID we want to put on our main frame top left rectangle corner, which the rectangle corner which we are drawing with the help of supervision. Simple. And then we want to mention the coordinates. So coordinates, let's just say x1 and y1, which is our rectangle top left corner. So x1, y1, and then we will mention 1 and 1, the rectangle size and the text size. Save the code and run the code. Now here, as you can see, we are drawing the track ID also. We are putting basically track ID on the rectangle top left corner. So let's just say here I will mention minus 10, and now if I save the code, if I run the code, it's good. Now let's just start our while loop. Let's just start our while loop, and then here it is. As you can see, the 15 ID is there. So this is what our ID 15. Then we have here ID 23. Then we have here ID 12. If I make like this way, here it is. As you can see, ID 12, ID 26, ID 30 is there, ID 33 is there, ID 28 is over here. Here it is. As you can see, ID 28. Simple. So friends, this is how we can call detected object coordinates, or we can say simply detected object points in Pygame. I hope you will learn something from this video. We will meet our next video. Till then, thank you, take care, and bye bye.